All right, on tonight's episode of Python Papi, we're back inside our generative AI course. Let's have a look at what we went over tonight. Last night, if you recall, we went over the concept, or the last concept we went over was the encoder decoder. Today, we're going to pick up where we left off. So, in the encoder decoder, the first segment is the encoder, and the second segment is the decoder. And in between, we actually have the context vector. As you can see here in this graph I drew here, we have the encoder here, our context vector, and then our decoder. So, our encoder and decoder are connected by the context vector. This model specifies that whatever information that we pass to the decoder from the encoder is passed through the context vector. So whatever information is coming from here, going to here, has to pass through here. However, in the first versions of the encoder decoder, the architecture was unable to handle longer sentences with more than 30 or 50 words. It was not able to sustain the context. Now, what makes up the encoder and decoder? Inside of our encoder decoder architecture, we'll find the RNN, LSTM, and the GRU. Let me go down so I can give you a look at that. You can see here our RNN, LSTM, GRU, and our RNN, LSTM, GRU. Now, it's not saying we are specifically using all three at once, but we can be using any one of these at any given time inside our encoder or our decoder. Now, back to the issue that we were discussing about the problem with the many-to-many sequence mapping regarding classical memory, where there is a restriction that says that the number of values entered into the input has to be the same number of values that come out of the output. Using the encoder-decoder architecture, we can solve that particular issue. But here, also, we're having an issue where the encoder-decoder wasn't able to handle sentences with more than 30 or 50 words. This is where our next concept comes into play. This is the concept of attention. Basically, attention was another way of mapping. So let's say we have 5 words in the encoder. Attention would try to map each of those words and look for a corresponding word in the decoder. In essence, trying to match the words in the input to the words in the output. And because of this, it was able to make predictions. So whatever longer sentences we had as input in the encoder, it was able to predict if there was a match for it in the outcoder. Let's go down a little bit more. This is our new context, or this is our new graph here showing our new mechanism, which is attention here. As you can see, we still have our encoder, we have our decoder, we have our context vector, and then we have our new attention mechanism here. So in later versions of the encoder-decoder, it became possible to map the inputs to outputs without using RNN, LSTM, or GRU. This means that in order to use the encoder-decoder, all we needed was the attention mechanism. So for example, if we were passing in an input into the encoder with a text larger than 30 or 50 words, the attention mechanism was all we needed to generate an output. I'm going to leave it there for now. We did start a new concept and started going with some other things, but I'm not going to start that tonight. Like I said, I want to take it slowly to make sure I have a grasp on everything in the beginning. So when we start moving forward and start getting deeper, I have all the basics under my belt and I can stand on foundation. Of course, we will pick it up tomorrow, and I will keep you posted every step of the way. But for now, this is Python Papi. You guys stay Gucci.